Hi students, welcome to Veteach app. In this video, I will explain about super mesh and as well as super node. Students, previous videos I explained about mesh analysis and as well as nodal analysis. Right? By using KVL and KCL, we find the unknown values. But what is the importance of this super mesh and as well as super node? Super mesh. Mesh is different to the super mesh. Node is different to the super node. Means something special is there. What the special is? Today in this video we will discuss. Right. Super mesh is nothing but what? It is there only one current source between two meshes. Right. Two loops are there. In two loops, if only one current source is there, the current can passes into two loops. So we don't have write two relations, two loop equations. Instead of two, just we take only one value. That value is nothing but what? A current value. So it is given network, it then is difficult to apply the mesh analysis. When two loops are there, in between a current source is there, then to write the relation it is somewhat typical. Right? First of all, find the node analysis, I can apply the mesh analysis and find the unknown. So for that purpose, what here happens means that irrespective of the relations, if we minimize the relations, that is nothing but what? That concept is nothing but what? Mesh analysis, super mesh analysis. Right. Here, this difficulty can be avoided by creating a super mesh which encloses the two meshes that have common current source. Common current source. Students, you know the mesh meaning? It is a loop. So here, how to find the super mesh is very important here. Right, students? See here, this is a network given. Okay, how many loops are there? Three loops are there. How many voltage source is there? One voltage. This voltage source, two loops, we have one current source is there. Two loops, one current source, I1 and as well as the I2. So irrespective of writing I1, I2 here, by using this current source, we can minimize the relation. Right? So here some steps are there to write the relations for super mesh analysis. That is, first identify the position of the current source. Yes, we identified how it is in between two loops, one and as well as the two. Hence the current source is common to the meshes of 1 and 2. So super mesh is nothing but the combination of two meshes. Right? So these two, only one current source, one relation we will write here. Now applying KVL to super mesh and no other meshes. So applying KVL to the super mesh, what happens here for this one? How many resistance are there? R1 and as well as into I1 and R3 into I2 minus I3 is equal to V. This is the total mesh equation. Right? R1 into I1 is a loop 1 and as well as the R3 into I2 minus I3 is the third loop. Okay. So for this, what happens here? Third loop relation R3 into I3 minus I2 plus R4 into I3 is equal to 0. This is normal KVL equation we can write here. Right? But what happens here? That I1 minus I2 is equal to 1. Here the special difference is here I1 minus I2 is equal to I. This is about the super mesh. Means in respect of two relations, just you are taking only one value. That value in terms of current is total current I. Same current flows here and as well as here. So two relations we are connecting only, writing only one value, right? So you can substitute these values also in other and we'll find the values. Now here we'll solve one problem here. Okay students. Now here loop 1, loop 2, loop 3 and here voltage source is there and as well as the resistance are there. Okay. Now what happens here? 1, 2, 3 loops are there. 1, 2, 3, 4, 5 resistance are there. Yes, the voltage source is there. Right? So what we have to see first of all, where we have a common current source. Where we have a common current source. The source in between mesh 2 and as well as the 3. So mesh 2 and mesh 3, what is the current source here? It is 2 amps. Here 2 amps. The current source exists between 2 and 3 mesh. Hence super mesh is the combination of 2 and 3. As already explained. By applying a KVL to the super mesh, we apply a KVL to that super mesh here, then what happens here? That it's how much current is there? It is 2 amps current is there across 3 ohms. So 10 into I2 minus I1 plus 2 into I2 plus I3 plus 5 into I3 minus I1. This is the total super mesh equation we can write. If you simplify that one, we will get this value. Now apply mesh to 1, first mesh. So what happens here? 10 into I1 minus I2 plus 5 into I1 minus I3 is equal to 50. Okay students. So apply here 10 into I1 and as well as the I2 and 5 into I1 and as well as the I3. Right. So what happens here? So we have I2 minus I3. How much current is there? 2 amps current is there. Now if you write the three different relations, and we will find three different types of currents, that is I1, I2 and as well as I2. But this is a super mesh of current in between mesh 2 and in the same way if we go for a one more method, that is super node method. Previous super mesh analysis, here super node analysis. Nodal analysis and as well as super node analysis. What happens here? In mesh we discuss about the current source. In nodal analysis we discuss about the voltage source. Okay, here also it is a connecting between two nodes or three nodes voltage source, we can convert into a super node. Okay, a super node is considered by two adjacent nodes that have a common voltage source. What we have? A common voltage source. Now see in this network what happens here? This is 1, 2, 3, 4 loops are there. Here current source is there. This is Vi. So here Vx is there. Vx is lies in between what? V2 and as well as the V3. So this node 2 and 3 are adjacent to each other, and this node we are saying as a super node. We are saying as a super node. So how to write the steps? What is the procedure to write the step? Identify the position. Yes, I already identified that where it is source. Apply KCL to the super node. What you have to do? We have to apply the KCL. Before it is KVL, here it is KCL, right? So what happens here? V2 minus V1 by R2 plus V2 by R3 plus V3 minus Vy. What is the meaning of Vy? Vy is nothing but what? A difference of two voltage sources plus V3 by R5 is equal to 0. So this is equation number 1. And for mesh for 1, if you write this one, this will get this relation. Make the relations between the node voltages, right? Then Vx is equal to what we can write here? V2 minus V3. So this is very important in super node analysis. Now solve the above nodal equations and get the nodal voltages. Now if we determine, if we do one problem regarding this super node, see here V2 minus V3, what it is? It is 20 volts is there. Here current source is there. 1, 2, 3, 4, same are there, right? Now applying KCL to the node 1. This is node 1. V1 by 3, right? And V1 minus V2 by 2, okay? And is equal to current 10 amps, right? If you simplify this one, then we will get 0.83 V1 and minus 0.5 V2 is equal to, here 20 volts nothing but V2 minus V3 is equal to 20. Yes or no? V2 minus V3 is equal to how much here? 20 volts. Now apply to the super node at 2 and 3. Node 2 and 3. What happens here? V2 minus V1 by 2, V2 minus V by 1 and V2 by 1 and V3 minus 10 by 5, V3 minus 10 by 5 and V3 by 2. So this is the KCL across node 2 and 3. And the third equation is nothing but V2 minus V3. Okay. So if we substitute these values, solving the above equations, then what happens here? V3 is equal to, we will get minus 8.42 and current across 5 ohm resistance is, that is I5 is equal to minus 3.68 and the negative sign indicates the current flows towards the node. Means here we have to change the direction across the node 3. Okay. So like this we will find the super mesh and as well as the super node, right? So mesh and super mesh, node and super node somewhat different here. Okay, we are minimizing the relations and we are finding the unknown values. Okay students, thank you.